Hi guys, and welcome to another video. And in today's video lesson we're going to be looking at grade 12 maths probability, and the sections that we're going to be looking at is two-way tables and the fundamental counting principle. And this question appeared in the February-March 2016 paper 1, and it reads as follows. It says in question 10.1, each passenger on a certain Banana Airways flight chose exactly one beverage from tea, coffee or fruit juice. The results are shown in the table below. So here they say that we have male and females and tea, coffee and fruit juice. We have the total number of males is 60, the total number of females is given, which is 100. And the first question that we have is write down the value of A. So the value of A can be simply 60 plus 100, which is equal to 160. So that's a cross, or you can go down and add up everything. 80 plus 20 is 100, plus 60 is 160. Then it says, what is the probability that a randomly selected passenger is male? So therefore, for a male, the total number of males is 60, so that'll be 60 over 160. So for this question here, the probability of that event occurring will be 60 over 160, and we'll simplify that. We'll write the solutions neatly in a moment. Now it says here that given that the event of a passenger choosing coffee is independent of being a male, calculate the value of B. So they are telling you here that they are giving you that coffee is independent of being male. You want to calculate the value of B. There's B here. So let's look at coffee. Coffee, we'll call it C, and male, we'll call it M. So they are telling you that the probability of choosing coffee, so it's coffee and male, is independent of being male, and the rule for independence is the probability of C and M must equal to the probability of C times the probability of M. So if we can now substitute into this equation, we will be able to solve for B. Let's go write our answers down. 10.1.1, the value of A was 160. So let's go write that down. So 10.1.1, A equals to 160. 10.1.2, what is the probability that a randomly selected passenger is male, and what did we say? That one will be probability of male is the total number of males is 60 over the total number of people on the plane, which is 160. So we can write down 10.1.2, the probability male equal to 60 over 160. That's equal to, so let's simplify that. 60 over 160 is 3 over 8. So therefore the probability that someone is a male is 3 over 8. 10.1.3, given that the event passenger choosing coffee is independent of being male, calculate the value of B. That's a very important rule. We are given that probability of coffee and male is independent, therefore the probability of coffee times the probability of male must equal to the probability of coffee and male. So therefore, what is the probability of coffee and male? The intersection of the two is B over 160. Let's write the statement down here first. 10.1.3. So I'm going to write down the statement. Probability of coffee and male is equal to probability of coffee times the probability of male, and that's for independent events. Probability of coffee and male will be B over 160, the total number of people on the plane. So that's going to be B over 160 equals to probability that somebody likes coffee. So coffee, the total number of people that like coffee is 80 over the total number of people on the plane is 160. So 80 over 160. That's going to be 80 over 160. Probability that someone is male And that's we already worked out, but let's write it again. That would be 60 over 160. So that's 60 males over the total number of people is 160. Therefore, B will equals 2. So let's cross multiply 160 times 80 times 60. So I'm just cross multiplying there, and that's going to be over 160 times 160. Let's go and put that in our calculator and see what we get. So therefore, now we'll get 160 times 80 times 60 all over 160 times 160 equals to 30. Therefore, we can conclude that B will equals to 30. Let's look at the next question. In the next question, it says a Banana Airways aeroplane has 6 seats in a row, or in each row. How many possible arrangements are there for 6 people to sit in a row of 6 seats? So this question deals with the fundamental counting principle. So this now will be 6 factorial. How many possible arrangements are there for 6 people to sit in a row of 6 seats? So 6 factorial. Next question, Koliswa and Anis and 4 other passengers sit in a certain row on Banana Airways flight. How many different ways can these 6 passengers be seated if Koliswa and Anis sit next to each other? So for 2 people to sit next to each other, so we're going to group them, Koliswa and Anis, and let's put them as 1 and 1 sitting next to each other. And then we'll have the 4 other passengers, which is 1, 2, 3, 4. So this is now going to be Kolisa and Anis can sit in 2 factorial different ways. And they are now one group, so they will move together as one unit. And with this 1, 2, 3, 4 other passengers, we'll now have 1, 2, 3, 4, 5, because we're counting Koliswa and Anis as one group. They can now be arranged in 5 factorial different ways. So answer there is going to be 2 factorial times 5 factorial. So we group the number of items that have to be or have to remain together. So Koliswa and Anis must remain together, and they will remain as one group. With the 4 other passengers, remember, they can be arranged in 5 factorial different ways. And in the last question here, we say 10.2.3, Mary and 5 other passengers are to be seated in a certain row. If the seats are allocated at random, what is the probability that Mary will sit at the end of the row? Now, there's 6 seats, so 1, 2, 3, 4, 5, 6. Now, if Mary has to sit at the end of the row, Mary will sit at this end. Then the other passengers can be arranged in 5, 4, 3, 2, 1. So 5 factorial different ways. Or Mary can sit 1, 2, 3, 4, 5, 6. So if Mary is going to sit at this end, she's going to be there now. And the other passengers can be arranged in 5 factorial different ways. So it's 5, 4, 3, 2, 1. Therefore, my answer will be 2 times 5 factorial. So basically, it can be 2 times 5 factorial different ways if Mary is going to sit at either end of the row. But they asked us for the probability. So therefore, the probability of this event occurring will be 2 times 5 factorial all over the total number of possible arrangements for the 6 people to sit in a row of 6 seats. So that will be all over 6 factorial. Now, let's go write our answers. 10.2.1. 10.2.1. Once again, they said how many possible arrangements are there for 6 people to sit in a row of 6 seats? So that's 6 factorial different ways, which is equal to, you can put that in our calculator. That will be 6 factorial equals to 720. 10.2.2. They say Khalifa and Anis and 4 other passengers sit in a certain row on a Banana Airways flight. In how many different ways can these 6 passengers be seated if Khalifa and Anis must sit next to each other? So I'll explain it one more time to you. If Khalifa and Anis are going to sit together, they must remain together as one group, and the 4 other passengers, 1, 2, 3, 4, 5, 6 in total, Khalifa and Anis must be together. So therefore, Khalifa and Anis can be arranged in 2 factorial different ways, and they must remain together as one group. So it's going to be 1, 2, 3, 4, 5. Now everybody can be arranged in 5 factorial different ways. Let's put that in our calculator. So that'll be 2 factorial times 5 factorial equals to 240 different ways. The last question, 10.2.3. So here we got Mary and 5 other passengers are to be seated in a certain row. If the seats are allocated at random, what is the probability that Mary will sit at the end of each row? And then we did the working here. If Mary wants to sit here, that will be 1, and the other passengers can be arranged in 5 factorial different ways. If she sits at the other end where she's going to sit here, the other passengers can be arranged in 5 factorial different ways. But this question asks for the probability. So therefore, our answer will be as follows. The probability of this event occurring will be 2 times 5 factorial over 6 factorial. 2 times 5 factorial all over 6 factorial. And that will equal to 2 times 5 factorial all over 6 factorial equals to 1 over 3. So the probability of this event occurring is 1 over 3. And as if you have not subscribed already to JL Maths, please do subscribe and share this content with your friends in your school or other schools. Also like my Facebook page, which is Justin Lazarus Mathematics. You can watch all videos in order of the work schedule, jlmaths.com, and I'll catch you in the next video.